say that. Anyway.
So, if you sold this piece, which was actually flown, how much?
All of these have flown. All of these have flown.
Yeah, okay.
A piece like that, I don't know. Since we're getting farther and farther away from Space Shuttle, my friend Ken Habicott is a collector. He sells a bunch of things. He's down in Titusville, Florida. Actually, no, close to Titusville. He's right outside KSC's gate. A piece like that he would probably sell since it flew. Since it's on the smaller side, I would say $350 he'd sell that for. Yeah.
Okay. And what's his name?
Ken Habicott.
How does he sell it?
I can write it down.
On eBay?
No, he's first started out selling covers. Those are the envelopes that have the stamp on it and decoration on it. And then from there, he started selling blankets and everything else. Let me write
this blanket's flown though?
Yes, it is. That goes. See, it's even got. Well, yeah, you can see the parts. That's the part number and everything on it.
Oh, okay.
But that would be with the payload bay doors open. That line the edge of the very edge of the payload bay door.
Like
if
where?
the doors were open.
Oh, like
if I could open
doors.
up the door.
Yeah.
There we go. That blanket would be right there.
Okay.
Right
at the
there.
edge. Okay.
And you notice, I'm going to show you, pull it out. This is beta cloth, and this is flown. When we made this blanket, it had a 1" by 1" aluminum screen here because when the door shut, it compresses the blanket, so the air has to have a way to leave.
Yeah.
But whenever we built this part, we always had to recycle this one. I don't know why. This was the only part that we recycled. And so that's why you can tell it flew, because we only take the screen out when we're done with it, and we can build another one. But that is a flown one. This is beta, and I can tell by the grid work. We went to a 4 by 6" grid work with our Inconel wire thread. The newer blankets that we built were 4 by 6"
Now,
grid.
was there something inside the blanket, like a piece
batting?
of
No,
ceramic?
just batting. Yeah,
Oh,
just
just
batting.
batting?
You feel it right there, just there.
And that's the space shuttle.
And this is the space shuttle picture that I took, and I have that again. That's flown, but I have 2 samples here. Whenever we built the blanket, we here we go. I know it sheds. This one is heat clean. So we have that, we bake it in an oven for 650 degrees for 4 hours and then 850 for 2 more. This is what the machine...
After you sew it?
I'm sorry?
After you sew it?
Oh, actually, the machine I have let me show you. This is the machine that we actually quilt the blanket with. There we go. That's called a production unit. Let me put that down there. Anyway, it makes a 30 by 30" piece of fabric, and from there we would cut it to whatever we needed. But this is what the fabric, this is a class 4, which is, this is one of the thinner blankets we built. We go from probably about 1/8 of an inch to 2 inches thick. And the class 11s, which are the 2-inch ones, go on the ohms pod.
Yeah.
But this is the blanket. This would be what it would look like before I would put it in the oven, and this would be afterward. But this one, like I said, is a 4. I can tell by the thickness. And this is quartz batting, quartz thread, quartz fabric, and this is fiberglass. And after heat cleaning, it turns white.
Oh, okay.
But anyway, these blankets here are all class 4s on the shuttle. This is why I brought the sample, so you get an idea. And then afterward, after they're baked, then they come back across the street to be installed with RTV, which you can see the RTV here. That's like a reddish blue that we used. It stands for room temperature vulcanization. And then it would have 2 coats of ceramic coating called Ceramic 9, C9. So it'd be a clear coat, and then 8 hours later we would put a white coat on it, and it would stabilize it and make the fabric shine like that when we were done.
Okay.
So, yeah, this is the machine. There's only 2 in the United States. We have one in California and one at Kennedy, and this is a polyimide blanket, and this is polyimide. So that's what these are.
And that's made out of what?
It's a type of special film. I should know and I don't, but this is a flown one as well.
Okay.
But I pulled this out because you don't see these blankets. We had over 5,500 of these that we built 2 different ways. We had one with a blanket TCS, which means this one has batting, but then I would also make one, same one, but it would have, it's called multi-layer, and we would have all these layers inside of one.
Oh,
so
okay.
I would make a matching blanket.
Where would that go on the shuttle?
Right here, inside the walls. In fact, this film is
Like when you open it up inside
it would be underneath all the white payload bay blankets.
Okay.
Anyway, so when you open up the payload bay door, these blankets would be in all the walls, the bulkheads. You don't see these blankets, but this is the film that protected the astronauts from radiation. So we built about 2,200 of these,
They're inside the cab?
Yes.
Cabinet?
Oh yeah.
Okay.
These would be blankets you would never see. You'd never see these. They're underneath everything. That's the thing. We did all this work, but you don't see them. And this one, we had about 2,300 of the beta blankets, which is a Teflon-coated fiberglass fabric. This is what the spacesuits are made out of. Also, what covers the Canada arms on the space shuttle is this fabric here. And then I have a piece of external tank foam from the last shuttle flight. My friend Scott Phillips, who's not doing too well. He's dying actually right now.
How old?
And anyway, when the program ended, his job was to be lowered into the tank. He's a skinny, wiry man, to check the seams inside. So we would shave the tank to make it more contoured. So this is the inside of what the tank would look like, and that's the outside. That's the thick
Piece of aluminum?
Yes, it is, and that's the same. That's the thickness that the orange tank would be. And you say it's not orange. That's because it hasn't been out in the sun. The sun turns it orange. So it's starting to turn a little bit because this has been out in the sun. But yeah, he gave me that piece. But now he's not doing well. I give him probably about a month. It's not cancer. He's got this disease. It's kind of like MS, but he can't talk now, and it's really sad. He's a really good friend of mine, and he lives in Huntsville. But anyway, so I just brought some of myself. Oh yeah, you buy this right too. Right here. This would be on top of the wing, halfway down the side of the shuttle, top of the crew compartment, and what covers the payload bay doors is what we call frizzy or flexible felt reusable surface insulation. So this is it's that thin. That protects to 750 degrees. These blankets won't even see 2,000. They don't even go anywhere near that. Probably closer to 1,300. Same with this one. And these are inside the wall, so that would be even less than that.
This doesn't get painted with ceramic, does it?
No. This is exactly how it is. That's an elastomer coating on the outside, so that's the finished product right there.
Okay.
But it's very thin, but this protects to 750, which, and this saved us over 1,000 pounds. And when we switched to the blankets, even though they're generally heavier, this 30 by 30 by piece, depending on the size of the tile, we could fit anywhere between 10 to 25 tile in that same surface area. So the blanket weighs heavy, but because it takes the place of so many tile, that's our weight savings right there. And that is, since it's fabric on the ohms, it's like I bend it, but I don't want to bend it, I'll crack it. But anyway, when we had the ohms, we switched to fabric. It was so much easier because it's a really tight curve. And when we had tile in that area, we used to call a dice cut, where we would cut a tic-tac-toe design on the back of the tile to get us the curvature fitting that we needed. Once we switched to any of the fabrics, this saved us 7,000 pounds when we switched to blankets, and then this saved us an additional 1,000 pounds. So in essence, Atlantis and the whole fleet of the shuttles we have left, she's the lightest. Even though we had Endeavour after her, we weighed them, and Endeavour weighs 3 more pounds than Atlantis. So Atlantis right now is our lightest shuttle. She saved almost 8,000 pounds off the first on Columbia. So, weight savings is important. It really is. We could save on fuel, and not only that, but we could take
save on fuel, you save on weight too.
Oh yeah, a lot of weight. That's why we quit painting the tank. We saved 650 pounds of white paint. After STS-3, we started not painting the tank.
What time did you fly out here?
We drove up here.
Oh, you drove from
Yeah, because look we have
Florida?
all this junk.
Oh,
yeah, whenever we come to NEAF, we drive.
Oh, okay.
And he has his children up here, so we stop and see them. They live in Lawrenceville, New Jersey, so we stop and see them. Lawrenceville. Yeah. And one of his daughters live in Cherry Hill, so we see
Cherry
them.
Hill. I'm from South Jersey, so.
Okay.
Cherry Hill, I used to go to Cherry Hill Mall all the time.
Oh yeah, we were just there. It's crazy. Parking is hard there. Anyway. And then I also have these other, again, these are also types of multi-layer blankets. So this is a Dacron mesh, and this is Kapton film. So when I tell somebody, oh, we have a blanket that's like 20 layers thick, they think, oh, massive. But this is what we have. Now this is a carbon fabric film, I should say. This is relatively new. I have friends of mine, we didn't use this one on shuttle, but my friends who work for JPL know I collect fabric, so they sent me a couple of pieces.
Do you go with him to take the photos of the launch?
Of course.
I don't know.
See, he credits all of his. I don't. In fact, I already have, since the pictures I took of Atlantis, I've already had, there's a women's group called Higher Orbits. They've already asked for some of my launch photos.
Oh, really?
And then we have at Astra Magazine, which is National Space Society, they called me up and said they wanted to use 4 of my photos that I took of the press site, because I take all sorts of pictures. It's like a carnival. When we had the launch, we have all the major new networks set up tents that are like 2 feet, like 2 stories high and everything else. So anyway, I've already had Astra ask for some of my pictures for their next month's issue. So yeah, I get around. I take pictures too.
Okay.
Well, it's funny you should ask that, because he credits his picture and I don't. So people always say, oh, did Ken take these? And I go, no, they're mine. So yeah, but no, all of these are his. I didn't bring any of mine because I've got enough junk. I have enough stuff.
Yeah, I hear you.
I got enough stuff.
All right.
Oh, so this right here, this is the example. These are the payload bay blankets, and the doors open.
Oh.
So that's where you see that. And this is me sewing thermal barriers in the nose landing gear door. Those thermal barriers are 4 feet long, and they take us about 4 days a piece to sew. And there's 2 chainmail, we have little coils that are inside of that to allow them to squeeze and we can flex. But it takes 2 of us 18 hours to sew 12 of those in.
Okay.
And we'll fly those probably 3 times, because that's a very critical area. The nose landing gear, this is actually, underneath here is the hottest on reentry, and everybody thinks it's the bottom, but it's not. That RCC is rated for at least 3,200 degrees, and our tile, which I didn't bring one today because I have 4 of them and they're looking a little rough, the tiles will only do 2,300. So this is a fabric, believe it or not. It starts off as graphite rayon, and then we layer it like fiberglass, but that'll do at least. But we have a curved panel underneath the nose called a chin panel, and we call that the shuttle smile. It's about this long and about this high, so about that long and about that high. And again, we have a little chainmail spring tube that we put inside, and that's all done by hand, and we compress the blanket down, stick it in that area, it pops up, and then we hand sew it around. So that's the hottest area, and everybody thinks it's the bottom, but it's not. So it's actually right underneath her nose here is the hottest.
That's not the bottom?
No, it's not the bottom at all.
Oh.
It's we have a little curved panel right there underneath
It's at the edge
her
of the
nose.
bottom, though.
I'm sorry?
It's at the edge of the bottom.
Yeah, it's kind of at the edge of the bottom, yeah. And then the second hottest is right here, right in there.
Okay.
And the reason why is, I will demo, as wheels shouldn't be depressing. As it's coming here, we have the plasma wicks its way underneath, right underneath the nose, and it also fans out this way. So these are the 2 hottest areas right here.
Yeah, they get the most of it. Yeah.
Oh yeah, and everybody says, well, why didn't we just cover, and I have a piece with me, let me pull it out. This right here we go, this is RCC, right here. So this right here, we have the 22 panels on the leading edge of the wing. This is what we call the T-seal. So this would be between, we'd have a panel here and a panel here, but this is the only sample I was able to get. But it starts off as graphite rayon fabric, and that's exactly, this is the hot stuff. That will do the 3,200. And the nose itself is probably maybe 2 inches thick, 3 inches thick, but inside the nose, we built hundreds of blankets called puzzle blankets that fit like inside, because that's the hottest area. But those are all hand sewn blankets that we did too. Okay. And I think I have tons of pictures, but I didn't put them all out. The inside of the nose is this right here. Let me orient myself. Yeah, there we go, right here. That's the inside of those. We're starting to take the blankets out to put new ones in, but this is inside the nose, and it's an official NASA photo, because you can tell that right there.
Okay.
Since I worked in thermal protection, sometimes if they were getting rid of stuff, they would let us have it. So I asked if I could have that one, because us ladies did make the blankets for the nose.
Okay.
So, but that's me inside of Discovery, and oh, there you go. Thank you. And then these are close-up. There's our Ohms pod blankets. This is by the nose right there. But I have a lot of pictures. The thermal barriers, thrusters, we all built by hand. There's 44 of those. And there's the second hottest area right there. But, and that's me in front of Atlantis. A while ago. But anyway, and this right here, the Armstrong brothers actually called me And this is fabric from the 1903 Wright flyer. And when the Armstrong brothers were having an auction to celebrate the 50th anniversary of the moon landing, they gave me a piece to cut so they could sell it at auction. So that's me cutting the fabric for them. So I'd have to say, working on the shuttle, that was probably one of the highlights in cutting the fabric for them. There's my schematic that I cut too. Oh yeah, I got to see a lot of neat people and all that stuff. So those are rainbirds that we can walk around in the flame. This is a flame trench. Those are our rainbirds that shoot the water out. So, and this is the oven that we bake our blankets in, and that's me underneath in the flame trench when Endeavor was on the pad. Right here. So there we go. I'm standing right there. But that's our pizza oven that we bake our blankets in. And there's a close-up of the blanket. This is our finishing. What we have to do is we have to knot all the way around, and then we flip the fabric and then hand sew all the way around. So I just took this picture so you can see the knots right there. But a lot of handwork on the shuttle. There really is. And that's me. Those are my hands. And this is a box that we put our production units in to put the blankets, and there's the machine again. There's a close-up of the needles. We have 30 of them. This is our top threads for the machine. And let me see what else. More multi-needle. It's called a multi-needle machine. There's another one of it right there. We haven't used it in a while, so we take the threads out of it.
It just happened, so I have just a
And there's
few of
another
them.
one. And this is
But I do
the
have them. There's the
machine
engine shot.
that
So
quilts.
you can
We
even
took
see
it
the
down.
RS-25s
That's a
there.
1914 Singer that we would use this machine to quilt the blankets that go around the engines.
1914.
It is.
Yeah.
He
I got so
started
many
off
more pictures
really
that was
small.
here.
I think I've got
Like
the
I said, it
picture
just
in
happened
here.
and I had to get the
Right.
dog. Here's
Yeah,
the
that's
engine
his
also.
name is Lurch.
Closed
So Lurch
there.
originally looked like that before we extended him out
Okay.
to this
But
right
this is
here
what NASA
to
does
that.
too.
So that's what he
What's the
looks like now.
distance right here?
It's roughly, I would say 6 feet. This is
showed
called the
them
throat, so that's probably about 5 feet right
And then this
there.
was, you
But
know,
anyway,
first
this is his
rollout.
original part, and that's the original
Rolling
part.
out right
This is the
back.
extension that we added to
And
him.
Isaacman was there.
Because
Come
this
to
is
my
what we
talk and
use
you'll
Lurch
see,
to quilt the dome heat shield blankets.
I got
That's a
lot to go
close-up,
through.
but this is a dome heat shield blanket right here. Right
They'll
here.
be
The
dragging
blankets
me
that
off
go
the
around the
stage.
engine, that's the ones Lurch would make. And we hand sew those on. These are done by machine and by hand, but we hand sew those on with
Yes, I
Inconel
know. He's
wire
a friend.
thread. So these again will
Oh,
fly
he's a great
roughly
guy.
3 times.
And,
So
and you know,
anyway, and
he's like the official.
these are we have horse collars, which are blankets that we make to go on the leading edge, and we use threads to pull them down into place, which is what you see.
But I'm not
Okay.
paid.
So
It's
that's
hard-
by
it's-
the wing?
So
This
if
is
you buy
yeah right.
something for
This
me,
is one of the
support
we have
around.
great. This is
I'm
RCC. So this one here, since we have that would be right in that area. There is where that picture would be taken.
Okay.
And this is the only, and this is RCC. That's a leading edge right there. It's a close of what it looks like.
Is that by the nose? Or the
No.
wing?
That's this. That's the curvature. These
Okay.
the panels are curved on the leading edge. This is the only blanket on the shuttle that we built that goes. This is where the external tank would attach. We had a panel of RCC covering it, but that blanket there would go. Well, this is not very good, but it would be right about there. It's where the external tank would attach itself because we had 3 spots here and 2 down there. And there's me. I'm inside of Discovery. This is at the Smithsonian. I was the last one to sew the thermal barriers inside of Discovery. So when I went up there to do a book signing, they let me hop over the platform and point out my pink stitches. So, and that's again me inside of Discovery. And then these are just close-up of blankets. See, some of these, like I said, in areas that we have to have access to, we'll actually put the blankets on a special panel and bolt them on so we can just unscrew the bolts and lift the section out to work on it. But 95% of the blankets are glued on the skin, just like this one is. And really, that's about it. I've taken so many pictures out of here. Anyway, that's about it. And this machine, the Park Service let me. This is inside of Dayton, Ohio. That's the machine that the Wright brothers used to do the initial sewing on their machine. But I have another picture of me. It's on my Facebook page, actually.
What kind of throat size is that? Is that like a
we're
normal?
talking. Yeah, that's a normal, but I would say it's probably that. It's probably about that.
Yeah.
Pretty machine. And I also have a picture of the sewing machine, not in here, of the sewing machine that they used in North Carolina. Addie Tate was the first postmistress in North Carolina, and they borrowed her sewing machine. It only cost her, I think they said $1.99, and it was an 1899. It was an 1899 Singer. They needed to shorten the wings, so they borrowed her sewing machine so they could shorten the wings. So I've been lucky enough to be able to hold both of those machines. So anyway,
Cool.
thanks.
Well, thank you.
Oh, thank you. Pleasure meeting you, Dan.